Welcome, everybody. I hope everybody had a good lunch and everybody's enjoying the conference. Thank you very much for coming to attend this session. I'm Trevor-Rowe, and this is my coworker, Lauren Siegel. We work together on the AWS SDKs for Ruby, as well as the AWS SDKs for JavaScript. But today's presentation is going to be focusing specifically on the AWS SDK for Ruby. I've been with Amazon for about 3 years now, and I've had the pleasure of working with the Ruby SDK, building it as an open source package, but more importantly, building an open source community. We've engaged lots of our users and integrated lots of feedback, and it's been kind of a long process bringing us to what we're going to be presenting today, but I'm really excited about it. I also would like to thank my wife. She's at home today with our 5 children, so this is my family. Simon, Boston, Audrey, William, and Dean. For those of you who were at the presentation last year, we had a presentation at Rerun last year. I shared a picture, so this is last year's picture. You can see they're a little bit older, but they're nonetheless crazy. They're still, don't let that other picture fool you. So today, the goals for this presentation are, we'll be introducing the new AWS SDK for Ruby Core gem, and I'll explain what that is as we go along. We're going to get some hands-on experience with it. We're going to be diving into the interactive console for the AWS SDK for Ruby. We'll also look at how the new SDK is more extensible, and we will actually be extending and modifying the SDK on stage and building something fun. And then we're going to talk about open source, how to get started making contributions, and kind of what that process is like. So if you are an existing AWS SDK for Ruby user, this is probably what you're familiar with. We have this gem called AWS-SDK. That's been out for about 2.5 years now. But again, what I mentioned, we keep mentioning this new SDK, and this is version 2.0. This is kind of a significant milestone for us. We follow semantic versioning, and part of that is promising to our users that we're not going to break backwards compatibility within the same major version. So just today we released version 1.26 and of the core SDK. But as we move into version 2.0, we are going to take the opportunity to refresh technology, incorporate feedback we've received over the last couple of years and everything. But why 2.0? Isn't version 1.0 of the SDK good enough today? Like, it does lots of things. It talks to all the services. We wanted to address some of those kind of nagging issues that people have been kind of suggesting and giving feedback that we've held off changing because we didn't want to break users. And that includes validation. We wanted to address how the response data structures were returned. We're addressing API reference documentation and increasing the visibility there. We've also made the client more extensible, and we're also trying to address consistency. It was an organic SDK that grew over time, and as we learned, things kind of changed a little bit, and in version 2.0, you won't have to worry about some of those differences. So today, we actually released this as dev preview a week ago. You can install it now, AWS SDK Core. You'll need to add a --pre right now until it exits the developer preview period. But this is on Ruby Gems and on GitHub now. The code has been available for a couple months. We've been developing it out in the open, collecting feedback from users who are interested in the new SDK. So I'm going to give you a little kind of a diagram of what this looks like. Version 1 of the SDK is it's kind of a monolithic single large gem. It is one gem for all services. It has clients, it has higher level abstractions, helper libraries. And in version 2, we're going to be breaking that up. We have a AWS SDK Core, which is what we've already released. And this is focused primarily on the client level abstractions. So you can expect inside of Core to have one class for every AWS service, and that class will have one instance method for every API operation. And the parameters that you pass into that operation method are going to match the structure of the service. So this is your basic client library without a ton of frills added on top. We are still working on what is the shape of the rest of this going to look like. We do know that we plan to develop it separately, so you'll be able to pick and choose which layer of the abstraction you want to work with. And you can, take or leave the higher level abstractions, but that is kind of our V2 strategy. Before we kind of wax long on this, let's actually jump into an interactive console. Lauren is going to be driving this demo. I'll be talking, but we're going to get we're going to get our hands dirty a little bit with the AWS SDK Core. Go ahead and increase the font size a little.
Yeah, let's bump it up. There we go.
Can everybody see that? We might, yeah. All right. So one of the features you may not know about is that AWS SDK for Ruby ships with an interactive a REPL or a console. And this makes it really easy to explore working with the SDK gem. So it ships with the AWS RB binary. If you do a -H, you'll get your command line help.
Yeah, let's jump that down a bit.
Is that good?
Yeah.
Okay. And so let's go ahead and just jump into it. From this REPL, you now have access to all the services. So let's go ahead and create a service client for the AWS S3 service. And we get back our client. And it's pretty basic.
If you want to see all the services, you can actually do AWS.service classes, and that will give you a list of all the actual service classes in the SDK.
Yeah, you can see that we support there's some 30+ services that we support at release. So you can, rest assured that any service that you want to access, you have programmatic access from the SDK. There are some helper methods for creating service clients. So just from AWS, you can do AWS.S3, you can get a client.
And if you're using Pry, you could just type S3 if you're using Pry as your REPL. You just have to type S3 and don't have to do the AWS prefix there.
Right. This interactive console is built on top of Pry. If you don't have Pry in your system, it falls back to IRB, but you lose some of the extra niceties that are kind of baked in. So once we have let's actually construct a service client. Each service constructor accepts a hash of configuration parameters. The default configuration for all services is to retry failed requests up to 3 times, and you can see that here. But let's go ahead and construct an S3 client with a different retry limit.
So we'll put a retry limit of 10, and then we'll look at that retry limit.
So it's pretty basic, pretty easy to use, and great. So let's actually make a round-trip request to a service. I want to see what tables you have in DynamoDB and limit it by 1. All API operations are very basic. They accept a hash of request parameters. Those should be a hash of symbolized keys, and it returns a response object.
So, right, let's just set that to response. And we have a response object here with the result of the request.
Right. A response object has interesting information. It has a .data property, which is what is being inspected by the REPL, and that'll be a structured response of all the data you got back from the service. It'll also contain all of the context of the request you made. This is really useful for debugging, logging, doing all kinds of interesting things. Context will have the HTTP request that went down the wire, the response that we received, the parameters that were present when the request was made, all kinds of interesting information. So this is part of the new extensibility thing. So once you've got your response data, let's actually look at a different operation. S3, let's go ahead and list buckets and map their names. One of my favorite features of the new structured responses is that you can access the response data using Ruby methods rather than strictly as a hash. This gives you a lot more feedback. Hashes are more useful, or can be useful, but structs are technically faster, and they actually give you a lot of feedback if you try to access something that does not exist.
So we're treating it as a regular struct. So we have a buckets object, and we can call it out first on this object. And then we have another struct object, and we could just call creation date. And this looks very Ruby-like. So
can we change the terminal background?
Let's see if we can change that terminal background. Yeah. Let's go to basic. Yeah. All right.
Is that better?
Does that work for everyone? Sorry about that.
Right. So structured responses. This is kind of a cool thing because if you were to access a normal hash and you ask for a property that doesn't exist, you get back a nil. And a nil value isn't really helpful because it doesn't tell you, was that value just not present or set, or did I typo something, or did I access the wrong thing? And this is not very helpful, so by using structured responses, you get a lot more contextual information. It also allows you to use both hash access, so you could access the creation date of that bucket similarly.
So you could do .color.
And it's going to let you know that that property doesn't exist. If you try to access that as a hash, it's also going to tell you that's not a valid member of that structure. So pretty cool. You can also always at any time take a structure and then to-hash it, and you'll get a deeply nested as a hash object back. And this is, so if you need a hash which is more portable, then you can still work with that. So this is cool, but one of my favorite features actually is the parameter validation. It's really difficult when you're calling an API operation and you're not quite sure what the structure is, and some of these AWS operations can accept a large number of parameters. And so let's take an operation like DynamoDB create table. That one accepts a lot of different parameters. But Lauren, why don't you go ahead and make a few mistakes and let's see what the
So you're
parameters
supposed to pass the provision throughput in, and it's supposed to accept read capacity units and write, but let's go and say we're going to do something over 9,000 and see what happens.
That's the kind of DynamoDB table I want.
Yeah.
Over 9,000. But you can see that we've got a couple of validation errors. There are, it let us know that we didn't actually pass the table name, and then the value that we did pass table was unexpected. So it gives you information. You'll also notice that it grouped together all 7 errors rather than just bailing out on the first one. So you get a lot more context. You'll see down there some of the last ones will say missing required parameters for provision throughput write capacity. So it'll give you the entire context for each validation error. So Lauren's going to try to fix one of those.
I'm going to try and fix the read capacity units because the error said I should add that. But instead of putting a number, which is what I should be putting, I'll put a string. And let's see what happens now.
So here it comes back with a different error. It says it should be an integer. So it's also giving you type safety guarantees so that you know that you're not just passing in the integer a and it's going to come back as a or string a and it's going to get munged into a 0 or something like that. So this is one of those features that we've added to the new SDK to really improve the experience of using it. That should guide it. But more importantly than just kind of butting our heads against the parameter validator, why don't we go to the API documentation? And we're going to take a look at that. So this is the new API documentation. This is built using Yard, which is actually a tool that Lauren is an author of. So Yard is a Ruby documenter, and you can see we've grouped all of our services on the left that we support, and there's a lot of them. But let's go straight down to DynamoDB, and we're using the latest API version. And so here's our documentation, and it's pretty straightforward. Let's go to Create Table, and there we go. It has API reference documentation from the service docs that have been pulled into here, so you don't have to jump back and forth. And then we also generate a formatting example of how do I call this operation. And this is actually something you could copy and paste. It'll pass parameter validation, and it'll make it to the service. Now, the service may come back and say, well, that's not actually a valid attribute type. It needs to be one of these particular values. But this gives you the entire structure and will guide you in how to use these API methods. If you move over to the next tab, we have this exact same structure given with the parameter that it should be, and if it's a string or array of strings or whatever, and it has the API documentation pulled into here. So really, you don't have to jump back and forth between service docs anymore, which is a headache that a lot of people said, this is interesting, but I have a hard time understanding how the SDK API maps to the service API. Now it's very, very clear. Let's go ahead and take a look at another service. You'll see EC2 is very, or actually back at the API docs. Yeah, so let's take a look at an EC2 client. You'll get the same level of documentation. Pick an operation, there you go, allocate address. And you see, you get the same thing. Much simpler API call, but you see that you need to pass in what's required and what's not. Go back to the formatting example. Also, you'll notice that it gives you VPC or standard. Anytime that the service expects one of a particular enumeration, it'll spell out exactly what the valid values are. So this is really to guide it and make this experience as seamless as possible. So I think that's enough documentation. We're going to jump back into the REPL. Before you fire it up, though, there's one of those flags that the REPL supports was -v, and this enters debug mode. So we're going to enter debugging. Despite your best efforts, you may find that you are running into a problem, and you want to see what's happening. Debug mode in the REPL enables both just the operation logging, but it also enables HTTP wire tracing. So if you were to call an operation like S3 list buckets, you're actually going to see the entire HTTP wire trace, including the XML response that they sent back that we parse, the headers you sent, the headers they returned, and this is just a really easy way to like say, wait a minute, I thought I set this parameter, where did it go? You can see where it went. Now, how does that work? It works because it's configuring wire tracing as a global default parameter when you fire up the REPL with -v. So let's talk about configuration. AWS.config, it's just a vanilla hash. You'll notice that there's a logger object that's hogging up a lot of space up there. There's a log formatter. Those were both added. And then there's at the very bottom, there is a HTTP wire trace Boolean. Those are treated as default values on any service object you construct. So if we wanted to disable that, we could construct an S3 object and just disable wire tracing on that particular object. And this will override the default value. And then if we made that same request with S32 list buckets, there's no wire logging. So AWS config is used for all of your default parameters, and they are merged in, but any runtime constructor options will override those. We could also go ahead and disable that and kill by replacing, by setting that value or just setting config to an empty hash, which would also kill our loggers.
And so now it's going to not show logging even for our default S3 object. It's going to no longer show logging.
Great. And in addition to AWS config being default parameters for every service, you can scope your configuration options with AWS config. So if you did AWS config we're going to up the max retry limit for DynamoDB. So, or for S3, it doesn't matter. So Lauren's driving, so we'll do S3.
Yeah.
So you can specify a hash for a particular service. And now if you were to construct an S3 client, you're going to see it has the new default limit. But if I constructed an EC2 client, it's going to have whatever the global default, which is 3 in this case. So you can kind of scope your configuration values that way. In addition to these, there's a whole suite of configuration values, but one of the feedback we got from users was I set a configuration value in the hash, and I didn't realize I had typed it wrong. And that configuration value wasn't applied, and so the client wasn't doing what I expected it to do. So we took our validation strategy, and we've merged that all the way down to configuration. So if I was to construct an S3 client, and I wanted to use path-style addressing, I wanted to access my bucket as a website with SSL, and so I want my bucket name to always appear in the path. I want to force path always to be true. So in this case, we set it to true, and then we go ahead and construct our S3 client. And we just realized, oh my goodness, it's not forced paths. Instead of silently ignoring that and just saying, I don't know what that is, we're going to give you feedback. So instead, let's clear out that value and set forced path style, which is actually the real parameter. And so you see you get that same kind of comfy feeling that you're confident that your configuration has applied and not been dropped. So now you can create an S3 client.
1 second. AWS config delete force paths, and let's set the force paths
under S3.
Oh, right, sorry. There we go. And let me just delete that thing from.
Yep.
I put it in the wrong one, so that should work. Oops. And we still have that.
Oh, so it's still under the nested S3.
Yeah, okay.
Okay, so yeah, we have type safety and configuration. As you can see, it's preventing Lauren from trying to use that option in the wrong place.
There we go.
That's cool. All right. There's a couple other things that we glossed over. You notice that we're round-tripping requests to services, but we have not actually configured our credentials. There are 3 required configuration values you must specify. You must specify the AWS region you want to operate against. Lauren, how did you do that?
So I actually put it, so you can actually set these things in your environment variables. So I have an environment variable set for my region, and you can use AWS_region to actually set your default environment variable, and that will be pulled into my configuration whenever I create instances.
Right, so the SDK will pull that in from your environment. It can load your AWS access key ID, your secret access key. It'll do all of those things for you. You can also statically configure those things. Just be sure if you ever statically configure credentials that they're not coming from files or anything that are checked into source control. It's generally a bad idea. It makes it very difficult to rotate your security credentials. So while it works, just buyer beware. So let's see. Let's talk about API versions. One of the things that we ran into during the lifespan of the AWS SDK v1 was a problem that we had to solve was services would come out with these really sweet features and they would add new operations, deprecate old ones, and now all of a sudden I had coded something against the service, but I wanted to take advantage of these new features, but it might break my code. Like, which API version do I want to use? Inside of AWS SDK Core, we actually ship multiple API versions for service clients, and you are coding against a specific API version. And so different API versions may have different operations. As you notice, anytime we construct a client like DynamoDB, you're getting back a versioned client, and that has a specific set of operations that accept a specific set of parameters. By default, we always default to the latest API version, so you always get the latest and greatest. But let's say I wanted to work against the 2011 API.
So you can actually figure out which API versions exist by actually just calling the API versions class method on the service you're using, and that will actually give you all the APIs that are available for that service. So Trevor was talking about using the 2011 version of this API, and we can actually do that by creating a new DynamoDB object with the API version option pointing to 2011, 12.05, and that will create a version of that older API.
To make this easier, you can also specify that inside of AWS config, and you can specify that DynamoDB API version, but there's a feature that I really like. We have introduced this concept of global API version locking. So you're sitting down, you're hacking out, you're using multiple services, and you want this application to run for a very long time, and you want to isolate yourself from API updates that might cause you headache. And so instead, let's just back up, and we're going to set API version to early 2012. We're going to roll back the time machine. It's 2012-0101. The latest DynamoDB API version has not been released, and so we're going to set config API version to that date, 12-0101. What this does is this is treated as a fuzzy API version because it's not for a single service. And so when you construct a DynamoDB client or an S3 client, it's going to take the client that's of the latest version up to that date but never beyond. And so this kind of treats it as a manifest so that you don't have to think about, okay, I'm using 10 services and I'm using these 10 API versions. You just say, what's today's date? Put that in, and now you can selectively move that date forward when you're ready to test against the newer API versions. So that's a feature that I'm really happy about. So that's kind of the end of our interactive part of this demo. We're going to kind of jump back to V2, and we're going to talk about some of the other kind of cool features. So some of the key differences. First off, you may not have noticed this right away. If you're a user of the existing SDK, the top level namespace is all uppercase AWS. This was coded under the new namespace A_WS. This was very intentional. It's under a separate gem, separate namespace, and this allows you to install the new SDK side by side with your old one. They are not completely compatible, but this allows you to start using the new SDK and migrate older code over as it comes in. So this is really a migration aid. You'll also notice if you're a user of the SDK1 that you may have run into situations where you needed to use the method aws.memoeyes. This is not something that I really particularly like about the old V1 SDK, and so we've gotten rid of that. You never have to worry about if I'm accessing response data, is it going to trigger another request? It's completely transparent. It will only make a request when you call that API operation. We also are only supporting Ruby 1.9+. 1.87 is end of life as of June. It's no longer receiving security updates, and so we felt it was important to kind of bring the SDK up to kind of Ruby best practices, and so Ruby 1.9+. We're also targeting Rubinius and JRuby and all these other really good Ruby implementations. Another thing that we changed is our dependency system. Under V1, we had a hard dependency on Nokogiri, which is requires libxml, which is a native C extension, and sometimes you might run into problems where multiple libraries want to use different versions of Nokogiri. No problem. We've moved away from this, and we're now using multi-JSON and multi-XML. This means if you want to use the ultra-fast OX and OJ libraries, you're good. If you want a library that you can push to a variety of environments and not worry about native dependencies, it'll fall back to RexML, which is Ruby standard lib, and JSON from Ruby standard lib. So it's really easy. You almost don't have to do anything for your dependencies. And then also I mentioned structured responses. You actually have a much better experience working with those data. What's coming down the pike? You remember in that diagram there was that big question mark for the higher level Ruby SDKs. We are looking in right now, and if you want to get in on the discussion, hop in on GitHub, because we're actively coding and we're looking for feedback. We're going to be implementing higher level resources so that you can have that object model on top of your buckets and your objects and your instances. Just like we have in Ruby SDK 1, we don't want to abandon that, but we're looking at how we can do this in a sane way so there's not as much handwritten code. We're also adding support for enumeration pagination. This one's really cool. If you've ever dropped into a client and made a call against AWS, you might have seen that the response is truncated and it gave you some of the results, and you had to extract some values from that response, and then you had to feed it back in as another request to get the next page of data. And you might have to do this n number of times to get all of the results. So we've baked into AWS SDK Core. It's a pull request right now, but it'll be integrated soon, where you can just ask a response to give me each page. So list buckets.each page, and you will get each page of response, or list objects each page. And this is really cool. We're going to be migrating over other helpers from V1. We have to look at those selectively and see how best they can fit into the new structure, but we're definitely doing that. And we're also looking at dividing each of the higher level abstractions into their own service gems. So you might see an AWS SDK EC2, which has special treatment for working with EC2. But we can kind of isolate those so that you can selectively pick and choose and upgrade those as needed. I also mentioned we're in developer preview. That doesn't mean it's not stable, but we are doing this so that we can put this out here in the public's eye. Rather than throwing something over the wall when we think it's done, we can put it out there and we say, we think this is stable, but we want you to check out this release candidate. Give us your feedback. We'll iterate on your feedback until we're happy and we can move it in. We really want to hear feedback. Customers are great at telling us what they need, and we definitely listen. We're also going to be introducing concepts of stability indexes to some of our newer features. And so we may roll something out into the public gem and mark this as experimental or unstable, or eventually promote it up to stable. And we'll make sure that those things are very transparent in the documentation so that you can see, you can try out some of these new features in your little test projects, but you know what we may still be working on. But we want you to use these things. I keep kind of alluding to the fact that the new SDK is more extensible than the old SDK. And this was one of the major reasons why we did this reworking of the client abstraction. We wanted to make it so that you guys could modify the actual client experience without having to crack open the code and monkey patch. This we felt was very important. So to do this, we are building off of a new architecture. Is anybody here familiar with Rack? The whole web service rack framework, right? If you're familiar with Rack, this should seem really simple. The idea is you want to make a request. It hits some terminal point. In this case, it's the cloud. And then you get a response back, and you want to modify that. Rack works by inserting layers or middleware onto a stack. And as the request travels up the stack, each piece of middleware can actually modify the request. So some of the default ones that we have the param validator. It's actually inserted into a request stack, and that's what does the param validation. And then after we're confident the params are valid, we'll actually serialize them to the body, and then eventually we send it, and that's where we send the HTTP request, get an HTTP response. We bring the response back down the stack, and we might parse the response into the structured data. But there's lots of other interesting middleware you can stick into here to modify the request and response lifecycle. We built the entire SDK on top of this concept so that everything we do is using the same interface you will use to extend the SDK. It gives us a large degree of confidence that it is extensible and that it's pluggable and that interface is solid and well documented. So, you know, again, I said here's middleware and there's kind of your rack application. That would be your send handler. This allows you to now write plugins. You can write a plugin, and this allows you to share code that you do when you use the SDK with many of your projects or with any of your peers as open source. The entire SDK is written in a series of plugins, but you could add more. Imagine writing a plugin that provides data checksumming of your object before it goes to S3 and computes the content MD5, sticks it into the header, so S3 will let you know if the data got corrupted over the wire. Yeah, that's a good idea. We should add that. You could extend the retry logic. You could remove the default retry plugin and put in your own that does custom retries that, for whatever reason. We get all kinds of these requests. Default parameters. I don't want to specify this particular set of configuration on this operation I call all the time. I'm going to write a plugin that provides default parameters. Or anytime I upload an object to an S3 bucket, if the bucket is my special bucket, I also want to send a message to SQS to say that a new object was uploaded. That would be very easy to do as a plugin. So plugins, handlers, context, there's going to be a couple words I'm going to throw at you, and then we're going to actually kind of put some of this into action. A plugin is nothing more than something that provides configuration to the SDK and then a handler. A handler is something that consumes options, or I'm sorry, configuration is an option with a default value, and then handlers are essentially like rack middleware. They have a call method, and they can build up the request or they can parse the response. And they have access to something called context. Context has everything about the request you care about: the operation that was called, the configuration, the request parameters, the HTTP request and response, the data and error that you should be sending back. It's kind of a very, very extensible thing. But let's not just talk about that too much. Let's build something. I'm tired of talking. Anybody here use Glacier? Okay, Glacier is an awesome service. It kind of struck me as funny, though, the very first time that I was using Glacier, that every API operation requires a parameter, and that parameter is account ID. And so I got very tired of typing account ID equals, and there's a special string. You can just use the hyphen, and that means my account, not somebody else's account, but my account. So instead of actually, having to put this into my code, let's write a plugin that actually applies this as a default parameter. To start, we just need to create a plugin class.
So I've opened up the terminal. I've opened up a Sublime editor here just to write out the plugin. We're going to require the AWS SDK first to
Core.
The AWS SDK Core first to actually be able to use it. And we just need to create a class.
So yeah, let's call it a Glacier account ID is our plugin class. And it's going to extend something called Seahorse Client Plugin. Okay, so I mentioned that we had this extensible kind of request response stack handling code. That's all done in Seahorse. So that's how we keep ourselves honest that if we can't write the business logic we want as a plugin and we're tempted to modify Seahorse, then we've done something wrong. And so that's kind of our logical separation. So this is all documented, but so to get started, we're going to plugin is a DSL, so we're going to define an option. This option will be the account ID. And what this does is this is going to let us specify, this is our default account ID. That's what the second parameter is. What is the default value for that? And then we will apply this to the request parameters when it has not been supplied. So that way you could always override this without having to modify configuration. The next thing that you need to do is actually modify the request. So there's multiple ways to do this. For this demo, we're going to use a very simple, it's called handle request. And that means we care about the request, not the response. And so what's going to happen is handle request is going to be given a, okay, so let's back up, you get to order your handlers.
Yeah, so there's a bunch of steps that you can actually run handlers at, and one of the steps is validate. It basically happens at the beginning of the steps. There's build and send and other steps. Right.
Validate, build, sign, and send is kind of your logical progression. You insert a handler at a step, and that tells it where in the stack it's going to appear.
And because we want to put in our option ID before we actually do parameter validation, we're going to set the priority And you can set priority to a number between 0 and whatever.
0 and 100?
Yeah, 0 and 100, and basically we're going to put it at 99. We want it to run before validation run so that we don't get a validation error when we.
Yes. Parameter validation will gripe if I've omitted my account ID, so we want this to happen before. This accepts a block, and that block is yielded the context. So the context has the request parameters, your HTTP request, your HTTP response, your everything that you really care about. But for this case, the only thing we care about is params. So context.params is what the operation received, and we're just going to optionally set, so conditional set on the account ID to be context.config.account ID.
The context.config.account ID is what we get from that option that we've defined above. And
that's pretty basic. So if we were to let's actually create a Glacier client right here, glacier.new.list vaults, but let's not actually apply our plugin yet.
So I'm just going to run this here.
And it says, whoa, missing required parameter account ID. Okay, so now we're going to go apply the plugin. So before we construct Glacier, we're going to do AWS glacier.add-plugin, Glacier account ID. And let's add a put statement on line 12. That way we can see the vaults, or do pretty print.
So we can see it nicely. So now, if our plugin gets added, we should actually get our
list of vaults. So it's that easy. As I said, you could have something that watermarks images as you upload them to S3. It looks at the HTTP request body, watermarks that image, resets the content length, and then uploads it. You could, the number of things that you can do with plugins are great, and it's really an exciting feature. Let's go ahead and jump back out. I've got a little boring slide right here. I apologize for the wall of text. But some best practices, I want to point out a couple things. I dropped the name semantic versioning earlier in the presentation. We make the agreement that we will rev the major version when we introduce backwards incompatible changes. So with AWS SDK Core, because we're looking forward, we're starting at version 2, even though it's a new code base. You should be able to depend fuzzy version on 2.0. And that will get you any version from 2.x all the way up to 2. Whatever until, but never including a 3.0. That way you can always update the gem with confidence that we are not going to break you. Also, if you are writing a third-party library or you are writing code that's not, for whatever reason, it's just a really good idea to consider locking your API version. That isolates you from service changes without even having to think about it, because you know that you'll always use the same compatible API version. And then lastly, when dealing with credentials, I also mentioned this, try to use rotating credentials. If you're using EC2, use IAM roles for instances. If you're on some other environment, load your credentials into the environment. Don't check them into your source control. It makes it very difficult when you find yourself in a position to rotate, that you want to rotate credentials, which really is a best practice. So, contributing. As I mentioned before, we have a lot of active users of the, oh, you had a question. Okay, so your question was with parallel requests. So, yeah, one of the things that we've done with this version of the SDK is we've taken a very careful look at making sure that it is thread safe. So in version 1, supporting Ruby 1.8 and everything, there's a lot of difficult things about thread safety. There are ways to work around it and whatnot. Using Ruby 1.9 and greater, you should be able to use the SDK with thread safety and with confidence that we are not sharing state between things, we're not storing things statically. So you should, with confidence, be able to do that. You can also do multi-process. You could also use a library like Celluloid that would hook into this and cause it to be an asynchronous request. Out of the box, it's not going to provide any asynchronous guarantees. Okay, and thank you. We will definitely look at, this is very early on, but this is something that we considered a lot as we were developing it, making sure that we did not box ourselves into, a particular, multi-process mode or something like that. So yes, we do care about parallel execution. So yes, this is open source. The best way to give feedback like this is to open up a GitHub issue and kind of pull our attention onto something. We check GitHub on a regular basis. We love to hear your feedback. If you find something that's not working right, whatnot, pull requests. They're very, very, we love those. You can also, if you find test coverage lacking, feel free to write a test. Let us know. We have worked really hard at making sure this is well tested, that the docs and guides, but there's a lot of places for contributions, sample code, and so on. So we believe firmly and strongly in open source. In fact, before we do this, let's jump back into the, let's do something fun. We wrote this plugin, and this adds useful functionality, but we don't want to be greedy. Lauren, why don't we share your contribution?
All right, so
let's make a GitHub pull request.
Let's turn this into a pull request. So let's take the code that I wrote here and actually pull it into the SDK. So I actually have a checkout of the SDK. So I forked the SDK into my repo, which is what you would typically do when you're creating a pull request. And I'm going to basically load up my version of that fork right here. And let's create a plugin out of that. And so we're going to go into the plugins directory right here in lib AWS plugins.
That's where we keep all of the plugins that we've built service support from. And so we're going to go ahead and create a Glacier account ID plugin, and we're going to put that in there. The only thing that well, first off, we're going to need to nest this. It's under the AWS module and then plugins module, just to keep ourselves consistent. So indent all that. Close that up.
Okay.
The next thing that we need to do is we need to add a, yeah.
Really quick, are there other plugins documented for each?
Yes, so we're not going to document this one right now, but we use yard tags to document them, and it's really kind of cool. Actually, go to the API documentation and bring up the constructor docs for,
Oops. Maybe that's to Amazon.
Yep. If you were to actually look at, I don't know, just go down to S3. We'll take the S3 one because we looked at that earlier. And scroll down to the constructor, go to the new. Okay, yeah, there you go. And look for force path style. That option is actually provided by a plugin. And if we were to go open up now the code for that plugin, so go back into your Sublime.
Okay.
And then open up the S3 path style plugin.
Style, S3 path. Is it path style?
I don't know. It's under plugins.
Oh, it's actually
Bucket DNS. Okay, that's
there we go.
Poorly named plugin. But if you look up just above, go to the top of this class. You'll notice there is a right there Seahorse client option. If you document your plugins this way, and we'll have all this documented so that you know how to, when you write a plugin, this will automatically get picked up by the doc generation and integrated into all the appropriate places under the constructor and AWS config reference documentation. And so yes, plugins, the list of plugins applied to a service are documented. They link back to them. If you go back to the ref documentation for S3, you'll actually see links to each of the plugins where that option is coming from. So we try really hard to make sure that it's brutally transparent where this came from, what that functionality was. And if you don't want that functionality, just remove the plugin. It's pretty simple. I don't want parameter validation. I want my request to hit the wire as fast as possible. I'm going for low latency. And I'm confident of my API usage. So I'm just going to remove the parameter validation plugin. You can do that. But so from here, we've created this plugin. We need to register it with autoload. So we'll go back into the aws.rb. And there is a plugins down here.
Right here.
Yep, we need to add a Glacier API version autoload. Oh, it looks like.
We're using account ID.
Or Glacier account ID, thank you. Yeah. Now, there's a couple ways that you could register the plugin. Right now, we're going to improve this process right now, but there is an API service translator. First off, let's go to API source, And we're going to go to, pick a service. Doesn't really matter. Just click on one. This is how the API works. Every single service client has this document that actually describes what endpoints can I talk to, what plugins are applied. If you scroll up, there's the list of plugins applied to the IAM service. And then all of its operations with their inputs and their outputs and what type of parameters they are. This is what drives 95% of the SDK. It's pretty cool. But we want to inject into this list. So there is under lib AWS API, service translators, one more directory up, service translators, and then there's a Glacier. And we're going to add a plugin to this. This is definitely something we're going to be improving, so it's much easier to register a default plugin so that you don't have to do it at runtime. But right now, this is how we're going to do it for this until we address this. And yes?
Yes, it is.
Yes. This is one of those big changes over V1. Everything you need to build the client, the source APIs, the API translator, all of the the client stack, everything is in the GitHub repository. There's nothing hidden. It's all there, and it's yes.
For example, if I wanted to document my own APIs in the same way, then I could just run your client creator over that, so I get the same thing.
Yes. In fact, if you just added a API source that had all of the files there, then our documenter, you could build a client for any API. It's very extensible. That's one of the design goals, that we wanted to make sure that this could be usable for more than just this purpose. You could extend it.
So in fact, that next step is we've added our new plugin into this list of plugins that we have to apply.
So we're going to generate the API.
We now need to regenerate the API, and so that is this very step that was just asked about. So we're going to do API translate, and then we're going to just do Glacier. And that will actually, if I do a git status, we see that we've modified the JSON. And if we go to the actual Glacier JSON file, we actually see that our plugin should be in that list. So it's right there.
Yep. So now rerun your example. Actually, let's just fire up the interactive REPL that ships with it. So bin AWS RB.
So we're inside the AWS RB, and now if we do glacier.listvaults, our plugin should be applied.
And it just works. All right, let's wrap this up. Let's contribute as a pull request. And
so we have a bunch of changes here. One of the things that we want to do with a bunch of changes is make a commit out of them. So we're going to basically add lib and APIs. And now we have a bunch of changes here. Let's just do a...
Oh, you need to add...
that's just
nope,
a
that's
test
good.
thing. So let's just see what those changes were real quick so we get a good overview. So we added this plugin to the JSON. We auto-loaded the account ID class, and we added it to the translator, and then we added our new actual plugin file. Once we have all those three things, we can actually make a commit message, and we can write a nice commit like
Glacier now has a default account ID.
Operations. So now we have a commit message, and I can push this to my branch. And I've pushed it to my branch now, and so if I refresh my page on GitHub, I have this commit right here, and if you see right there, there's a pull request button right there. GitHub makes it really easy to create pull requests out of changes that you've made to your fork. You can just click pull request, and all of my changes are here. And I can click to create a pull request. And so I can just basically say, I don't really have to put a descriptive message. You probably want to put a more descriptive message, but this is pretty good for the change that we have. I could send a pull request. And now there is a pull request against AWS SDK Core Ruby that we can actually evaluate and see if it'll work and get it into the SDK. One of the things that you'll probably want to do before you actually submit a pull request is we love tests. We have a lot of tests in our SDK. We actually have a really good test suite, and it runs really fast. You just type rake. So we do like it when you write tests. If you're going to make a pull request, it would be awesome if you could write tests for it.
Don't worry, on Monday I will submit back feedback on this pull request.
Yeah, that I don't have tests. I don't have tests in
Did
mind,
not test.
So we can't actually, we're not going to accept that because it doesn't have tests. But writing tests is very helpful. If you have problems writing tests, feel free to submit a pull request and just say hey, I don't really know how to test this, and we'll definitely come in and say, We'll give you feedback on how you could actually test it. We're pretty good at trying to help
Quite a
that
few
out.
people have made their very first open source contribution to the AWS SDK for Ruby, and we are very happy to help, give guidance. We're not scary people. We're pretty friendly. Let's just go back. We're going to show up a couple things, and then we've got to wrap this up on the presentation. So, back here. There's the GitHub repository, AWS SDK Core Ruby. We also have a blog that we blog on regularly about the SDK. We talk about upcoming features, new features that have been added. You can comment on there. And you can also go to the AWS forums, and we check that too. So we have a few minutes, and we're going to take questions at this time. So if you have questions, you can speak loud, and I'll repeat it. There's also a mic.
There's a mic right there. If you want to go and walk up to the mic, that would be the best.
Right here in front.
The context, is that split across requests, or is there a notion of session?
The context is unique for every request. So there is no shared state between one request and another request. It'll track down your parameters, your configuration, the operation. It'll actually have the service model for that operation as well. That big JSON document, that actually is loaded into an AST, so you know everything about that operation. And it will be unique for every request. Over here at the mic.
Yeah, quick question, waiters. Did you guys, I may have missed that, but did you guys talk about that?
Waiters are one of those features that we hope to add shortly. Okay. It's on the top of our our hit list. Pagination was first. Waiters is another low-hanging fruit. For those who don't know, waiters is a concept of when using AWS, I might spin up a resource, and I might be waiting for that resource to exit from creating to a pending to a running state. And I want to be able to intelligently pull that resource at a sane interval and bail out if it ever fails, or terminate normally when that resource is available. And yes, we do plan to add waiters directly to the clients. Actually, we'll go over here. I'll come back to you.
Is there a good way, if you're building a service with multiple dependencies, let's say like an ELB, which depends on a route to V3, is there a good way that daemons have to test this yet besides just maybe VCR? There's
Sure.
nothing really out there today.
So the question is, if I'm writing something that uses multiple services, what's the best way to test this? And he mentioned VCR. VCR is an excellent utility. How it works is you actually make a live request to a service, and something actually happens at AWS, and the wire trace is actually recorded to disk. And the next time you make that following test, you kind of load that fixture like a cassette and put it into your VCR, and it will replay it back. So it's more like a DVR, actually. But yes, so yes, you could use VCR, and that works nicely with the SDK. Another thing that we're looking at doing is migrating over the stubbed response plugin, or from V1 to V2 as a plugin, so that you could actually stub the responses, and it would just short circuit the whole stack and return your response data that you want, so that you could actually just say, we're looking into that, but VCR is a good way to test multiple services. Mocking and stubbing will be a first-class supported feature of this. Other services also provide really nice features, like DynamoDB has a local testing stack where you can actually spin up a local DynamoDB node, and you can point your development environment at that. There's also similar ones for S3 and other services. It can be more difficult for services that are more control plane, like EC2, where you're hoping that an actual physical server comes up. So we're looking into how to better, to support those testing things, but yes. Other questions? Over here.
Yeah, you mentioned loading credentials from a file. Is it compatible with the new CLI configuration files? And can you specify configuration profiles when launching loading files? Same way you can with the CLI profiles?
So we do not support those yet, though I think it's very likely that we would be able to support those. It would actually be very easy to write a plugin that loads those as defaults if that file is present. One of our goals is to maintain a consistent experience across SDK languages and tools, and so that's actually a very good idea that you just kind of gave me. So yes, let's do that. Thank you. We have how much time do we have? We have 60 minutes. So we have a few more minutes for more questions. Other questions? You had a question here in front, so yes.
What's happening to the high-level abstractions? Bits about the others?
Okay, so the question is, what's happening to the higher level abstractions? So if you're a current user of the Ruby SDK, about half of the services have hand-coded higher level abstractions built on top of the client. And we like those. They have some warts, things that we would like to have changed but have held off changing, memoization being one of them. We do not plan to abandon that concept. Instead, we're looking to migrate them over using a description document. Just like we describe the services, we want to describe the resources, in a kind of a RESTful, object-oriented manner. And that would provide you the same access to a service dot some resource name dot some nested resource name, and so yes, that is, we're actively evaluating approaches to solve that problem, but that is also, before we actually have a full V2 story, that will be in it. That is one of our high priorities. Other questions? Okay. Oh wait, we got one over here. So AWS SDK Core, I would imagine we're going to be in a developer preview for a few months so that we can give people time to kick the tires and come back to feedback, and if we need to change anything before we actually, full on 1 or 2.0. But that will happen long before the higher level abstractions are finished. This is why we're doing them as two different gems. So, you will continue being able to use AWS SDK gem version 1.0 or 1. Whatever while we do the 2.0 strategy, which is why we use the different namespace. Time frame, I can't really give a, there's a lot of, things we'd like to do for the higher level abstractions, so I don't know when those will be done, but I would imagine it's just a couple of months before Core goes GA. So, yes. Other questions? You had another one? Oh, okay. So the question was, okay. Any other questions? If not, then feel free to come up. Oh.
If migrating a project from the old SDK to this one, you say this is purely backwards compatible, or are there tips that...
Sure. The question is, when migrating from the old SDK to the new one, is it totally backwards compatible, or what are the differences? If you are using the client level of SDK v1 and not the higher level abstraction, I would place it as a firm 85% backwards compatible to the client of the new version. The primary differences are, we went to a model from where the AWS S3 client was hand-coded and much of the EC2 description was kind of hand-coded, to where we are using service descriptions that are shared by all the other SDKs. And so basically a couple of the response data structure parameters have changed in the S3 and EC2 clients. All the other services, you'll find that the clients are almost identical. Not in capability, but in the actual inputs and outputs. So yes, that's a very good question. And it is something that we care about, which is why we tried to keep them very similar. Any other questions? Going once, going twice? Sold. Come on up, and if you have questions for us personally, also please, please leave feedback. We really like to hear what you liked about this, what you didn't like about this. Next year here, don't talk so much, code more, whatever. Let us know, leave feedback, and thank you.